Good morning to everyone. My name is Jayashree. I'm your instructor. Uh, I'm going to teach you the subject probability theory and stochastic processes, which is a second year EC semester from JNTUH. So here, first of all, I'm going to tell you why here we are choosing probability. What is the use of probability? So here, basically, this probability it is used like it provides a language for people to discuss and communicate about uncertainty. Means here, most of the persons they will be talking about what will be happen. Probably it should happen like this. So here, all this which are going to happen, all these things are discussed as a uncertainty. And also this probability it provides a guidance for statistical decision making and estimation, and also it provides a modeling tool and ways to discuss the complexities of a given area, whatever the area we are choosing. So here basically this probability, as per the engineering point of view also, this probability is used in almost every branch of the engineering, like mechanical engineering or electronics or communications or electrical and electronics, any type of engineering, this probability it should be it is to be used. So the main applications of the probabilities means here where we can use these probabilities, how we can use. So here, if we are going to the first application, call centers and other staffing problems. Suppose in call centers, what is the use of call? Means what they will do, job of the call center people. So today they have to make these many calls. So how many people, how many staff members they are calling to persons, how many persons today, how many calls they are doing. Everything can be probably how many calls I can make. So that all these things can be applied using the probabilities. And in electronic circuits, suppose a circuit is designed, PCBs are designed. So what is the probability of getting failure? What is the probability of getting correct circuits? These things also can be used, means probability can be used. And here medical diagnosis and treatments. Suppose a person is having cancer. So for the cancer patient, what is the type of diagnosis we can use? Okay, and what is the type of the treatment we can use? Suppose if I use the one type of treatment, what is to be happen? So everything can be we can estimate by using this probability. Then next, information system, financial investment. Suppose if I want to do any new business, so in this business, suppose I'm going to invest some 1 crore rupees. So how to invest? What are the type? In which way we can invest? All these things also can be done by using this probability. Insurance industry. Suppose LIC policies. All people they are making LIC policies. So in this LIC policies, suppose I'm going to do LIC for 20 years. So in that case, how much interest I can get? Suppose if I do LIC for 50,000, how many installments I have to pay? Everything can be done by using this probability. And reservation system. Suppose if I want to go to America, so flight reservations. If I want to go today, in that case, how many seats are available? If not, then when seats are available, everything can be done by this probability. Then personal financial decisions. So these things all are the applications of the probability theory and probability theory applications. So here the first thing before going to starting our syllabus here, we will discuss what are the course objectives. So here by using this probability theory, we can be able to understand what are the random signals in this course. Instead of probability, we are going to discuss about the random signals also. So how random signals and processings are to be used, and how we can utilize the random signals in our communication theories. And also here we will be able to know what are the spectral and temporal characteristics of the random process. And then the last unit we will be going to learn about the noise sources to the course outcomes. So after going through all these topics of your probability theory, at last the student is to be able to understand what are the concepts of the random process and its characteristics, and what are the linear time invariant system for the random process, and here how to determine the spectral and temporal characteristics of the random signals or random process, and also the student he can be able to understand what are the concepts of the noise in communication systems. So here these are the course outcomes and course objectives of the probability theory and stochastic processes. Here basically in this 5 units, here we are going to discuss about probability and random variables. Okay, so in this probability, first of all, this first probability, we so here in our first unit, first half part, this is your property theory, which you already discussed. You know very well in the intermediate. Okay, what is the probability? What are the types of the probabilities? And what is the joint probability, conditional probability, total probability, Bayes theorem? Everything you know very well in your intermediate stage. And here we are going to discuss the new concept of random variable. So what is a random variable? What are the types of the random variables? What is the distribution and density functions? And what are the different functions like uniform density function, Gaussian density function, how to define, how to calculate all these density functions, everything we'll be going to discuss in first unit. Then coming second unit, here what are the different operations that we can use on a random variable. So first of all, single random. So here, in this second unit, first of all, we will be considering only a single random variable. After half of completion of this half unit, then we will be shifting to the multiple random variables. So here, operations. First of all, we'll be discussing of the statistical operations. Statistical means with respect to its time is constant for this random variable. Okay, so of all the statistical properties like mean, variance, moments, skew, all these things, characteristic function, movement generating function, all these operations will be performing on a single random variable. So after performing on this single random variable, here we will be shifting to the multiple random variables. Same mean, movements, variance, skews, transformations, everything we will be applying to the multiple random variables. Okay, so here in the second unit, we are going to discuss about the operations on a single random variable, that too statistical properties. To the third unit. Here, third unit, we are going to discuss about the random processes. What is here random process is nothing but here in the previous unit we have discussed with the random variables. Here, random process. Here, the time will be varying with respect to time. The characteristics of a random variable is going to be changed. So here, in this random processes, we are going to discuss different types of random processes and what is the stationarity of the random process, what is the split ordered stationary processes, what is the ergodic process. So, and here we will be going to describe, compare what are the statistical properties and this is temporal characteristics of a random variable. So after calculating, after coming to knowing all these properties, operations of a random processes, here we will be describing about the random signal response of linear systems. Okay, so in this after uh, calculating these random of linear system, here we are shifting to the random processes spectral characteristics. Spectral characteristics means it is a with respect to frequency. Okay, so here with respect to spectral is nothing but with respect to frequencies, and here in our third unit we are going to discuss about, we discussed about the temporal characteristics. Temporal means with respect to time, here spectral means with respect to frequency. Okay, so here in this spectral characteristics, here we are going to discuss about the power spectrum properties, correlation, autocorrelation functions and its properties. Okay, then after this, once again we are going to calculate what are the linear time invariant responses for the cross correlation and the autocorrelation functions. Okay, then in the last, coming to the last unit, here we are going to discuss about what are the different noise sources and information theory, because here basically we are as a communication, electronics and communication system engineers, here we have to know what is the noise and what are the source of noises, and how it is affects what is the temperature, noise temperature, the noise figure, average noise figure, everything we have to calculate. Because here in our future going courses in communication theory, basically in communication theory, we have to know what is a noise. Communication means here we are sending and receiving informations. Okay, so whenever you are sending and receiving information, some noise will be generated in the channel. So how the noise is generated, everything we will be going to discuss in the fifth unit. So after discussing about the noise, here we are going to discuss entropy. What is the average rate of information we can transfer? Okay, so different some coding techniques like Huffman coding, which are the errorless or error-free coding techniques, Huffman coding, Shannon-Fano coding, and what are the channel capacity? For channel capacity, we are having standard law, that is the Shannon-Hartley law. Using this Shannon-Hartley law, we can able to find the channel capacity. So these are all the things we are going to discuss in the fifth unit. Okay. So first of all, what is the probability and random variable, and then we are going to discuss about the operations on the single random variables. After discussing the operations on the single random variables and multiple random variables, and coming to the third unit, what are the different operations, means random processes for the temporal, that is a statistical characteristics you can say, and random processes for the temporal characteristics. And in the last, we are going to discuss about the fifth unit, that is noise operations. So hope you got all the overview of the your probability theory and stochastic processes syllabus. Thank you.